Hello, we're going to talk now about the second part of the sampling experimental design unit. Um, Previous video covered the sampling side. This is going to cover the experimental design side. And first of all, if you aren't running an experiment, then really what you are running in most any case is an observational study. An observational study would be situations where, like a survey or any situation where you are not necessarily inst applying a treatment or applying a change, where you aren't necessarily looking for cause and effect. So any time where you are not actively involved. Now there may be changes going on, seasonal changes, temperature changes. There may have been another dog who joined the other dogs at the dog park and that changed something, but you weren't applying the change in some sort of an experiment, and you weren't looking necessarily for cause and effect based on a treatment that you were applying or a change that you were applying. So observational study is really more of the visual measurement versus an experiment. So when you run an experiment, probably the most common types of experiments are the kind of the A/B testing, where you would have um, some placebo and then some new medicine or something, and you're basically seeing how people feel before and after these medicines to see if the new medicine helps them more. What you're doing in these situations is you're going to get some values out of that, and or some information out of that, and particularly if they are values, numerical values, you're looking for statistical significance. So you might then run a test, a statistical test, which goes back to the statistical inference idea from the sampling side of this, where you are looking for statistical significance. In other words, the change in how somebody felt from the new medicine versus the change in how they felt taking the placebo wasn't just zero point 0.1 difference on a 1 to 10 scale, and there were only 10 people in each group. It might have been a difference of 4 or 5 in terms of improvement in how somebody felt. And again, the statistical significance is going to be based off a number of things, like how many people are in each group, and what the average improvement was in each one, what the standard deviation was, and things like that. And so there's more to it, but you're looking for statistical significance, because simply a difference alone is not enough. You would need to measure and see if that difference is what we could term as statistically significant. Which, as you can see, just that it's something bigger than that could happen just plausibly by chance. An experiment, most effective way to show the relationship. When we talk about, you get a question commonly about, is this an experiment? Why or why not? And the rationale would be that you are applying treatments. In other words, you are changing something, like you're um, increasing a temperature, decreasing a temperature, adding a chemical, um, giving two different kinds of medicine, teaching a subject in two different ways, giving two different kinds of homework or something, where you're trying to make a difference in the response, and then you're using those treatments to look for their cause effect relationship, and then you're going to compare those cause effect relationships here, to see if the treatment that you applied, the change that you made, if that made a big difference or not. Okay. Um, a lot of times in medicine, experiments will be double blind. Not just in medicine, but medicine's a common one, because a lot of times a researcher has spent a number of years working on a medicine. And if he or she gets to run the experiment and know who's getting the good or bad, or excuse me, the new medicine, their medicine versus the traditional or some placebo, the researcher can then influence the experiment by saying, you're getting this new great medicine, um, or you're not getting the new medicine, you're getting the one that we're trying to improve on, or something like that. And if a researcher does that, then that, of course, can create some bias in there. Um, so a double blind experiment is where neither the researcher nor the subject, or the person receiving the treatments knows what treatment you're getting. Like I said, medicine's a big one, but also double blind might be if you're trying to push a certain product in retail or something like that. Match pairs is a certain kind of experiment, and match pairs would be like, if it was a Coke versus Pepsi, and you didn't just want 10 people to try Coke and 10 people to try Pepsi, you might actually run it as 10 people, and this Ari we'll talk about later, get Coke, then Pepsi, and then 10 people drink Pepsi, then Coke. And so they are really their own control group. So it's really a group of 20, and you're seeing how the Pepsi minus Coke or Coke minus Pepsi did. But the match pairs, again, is the notion that you kind of are your own control group here. That could be like your pre-test score to your post-test score. It could be husbands and wives are compared, and so rather than 20 husbands and 20 wives, it's really 20 couples. And so it's not as though you just pick 20 people who happen to be husbands and 20 people who happen to be wives. There is a pairing that's natural in there. Blocking is a big one from this unit. Um, Blocking is the idea that you are going to run separate experiments for separate groups or subgroups of your population. So, for instance, if I wanted to see how males versus females respond to a commercial for something like beer, um, I might run an experiment where I have the males in one group and the females in another group, and I split them up, and they get to see some commercial for beer or something, um, either once or no times during a half-hour show, and then we look at the response in terms of their purchasing of beer over the next month or 2 months or something like that, or 2 weeks even. And so blocking, what you're really doing with blocking is you are running uh, specific experiments for subgroups. Okay, and you are going to have separate conclusions. So you'll have a conclusion for males, you'll have a conclusion for females. You think about any population where you suspect that the results will be very different by subgroups. A common one would be in dogs. You don't want to put a Great Dane and a Chihuahua in the same dog food or dog medicine experiment because they could be influenced very differently by the medicine or by the food. So you might block by dog breed. You might not care what vet they go to. That was an old AP exam question where you don't necessarily block by what vet they go to or where the dog lives in the country or something like that, but you're looking at certain characteristics that really are distinctive for those for the parts of the population, which again could be gender, it could be breed of dog, it could be grade if it's an experiment in our high school where we're trying to see how ninth graders respond to something, and then how 10th graders, 11th graders, 12th graders respond to something. But blocking is you first just intentionally separate the groups, not randomly, but then once you separate them, then you'll still randomly put the groups into subgroups. And again, we'll talk about randomization here shortly. Experimental units are just on who an experiment is conducted or on what. Experimental units could be people, it could be cars, it could be dogs, it could be two different kinds of plants, could be two different kinds of basketball hoops. But the experimental units are on what we're applying this change to. Again, that could be making people try different kinds of soda or take different kinds of medicine, or it could be two groups of cars. One set of 30 cars gets a certain brake pad, and the other 30 cars gets another brake pad, or something like that. So in that case, the cars are the experimental units because that is on what we are applying our treatment. Subjects are just experimental units that happen to be humans. We try and humanize them a little more by calling them subjects rather than experimental units. So that's just um, the subjects are experimental units that are humans. Treatment, you've heard me mention that a couple times now. Treatment is the condition that actually is applied to the experimental unit or to the subject. So again, treatment could be the different brake pad. It could be different fertilizers for plants. It could be different brake pads for cars. Could be different medicines for humans. Could be different kinds of dog food for dogs. But the treatments are what is being actively changed or applied by the experimenter. Could be changing the temperature of something, could be cooking food at different times and temperatures to see what the best way for a certain frozen pizza to be cooked is. Um, Factor. A factor is kind of um, a more broad term, and I'll use an example here for this treatment factor and level. So imagine during the Super Bowl, a company is trying to decide about commercials. And so what they're trying to decide is how long the commercials should be, which could be one factor, and how many commercials they should have. Okay, so they're trying to decide 30, 60, or 90-second commercials, and do they want to have 2 commercials or do they want to have 4? Okay, so in this example, length and how many, sorry, that's how many, how many, okay, not much better, sorry. So the 2 factors would be length and how many commercials. Okay, a lot of times it's just one factor, which might just be temperature of water or type of dog food or type of brake pad or I don't know, type of fertilizer. But if you did type of fertilizer and watering, that would be 2 factors. If you did time that you should cook and temperature that you should cook, that's 2 factors. And then the levels are really the specifics amidst those factors. So in this case, we said length is a factor. It had 3 levels, 30, 60, and 90 seconds. How many commercials was a factor? It had 2 levels, 2 commercials or 4 commercials. Now you combine all those and you can see the 1, 2, 3, 4, 5, 6 going in the boxes. Those are 6 different treatments. So in this experiment, you need 6 different groups in order to apply those 6 different treatments to. I would say most experiments probably have 1 level, 1 factor with the 2, 3, 4 levels that we're worried about, but there's a lot that have 2 factors as well, or maybe even more. And that's the combination there. Treatment's the most important term. Factors has been talked about a little bit, which is just kind of the general, what are you changing? And of course, then the level is the specifics of that. Placebo would be kind of a dummy treatment. So that would be like in a lot of medicine experiments, they give a placebo, which is like a sugar pill that's obviously not intended to make any change, but just trying to see if people think that their headache should be better because they took a pill, even though it wasn't actually the pill that made it better. So that's a common placebo. Um, Placebo in other situations might just be kind of the continued status quo of something that's not meant to change, but is kind of the the fake treatment, if you will. Control group is really just about comparison. A lot of times the placebo group is the control group, but sometimes control is just, it's there for comparison. So for a pizza, the control group might be the current time and temperature, and we're just comparing new options to it. Or it might be the current fertilizer that we use in our garden, and we're trying to compare it with new fertilizers. So the control group is about comparison. Randomization. Okay, randomization is very important, and randomization is what we were talking about, or what I was talking about back up here when I put this RA up here. Okay, randomization is a common question that you would get perhaps on an AP exam, which is really when you have all of the people or items or whatever that's going to be in your experiment, how are you going to randomly assign them to the groups? You can't just say, you know, the tallest males, you get this medicine, and the shortest, you get this medicine. There has to be a certain way to randomly assign them. And again, that can go back to kind of the random sample idea, even though this isn't a random sample, because you may have volunteers, but now you're just randomly putting them into groups by saying, okay, we have 30 volunteers, everybody gets a number 1 to 30, and I put those 30 numbers in a jar and I mix them up, and the first 15 numbers I pick out, those people get the placebo, and the other 15 people get the new medicine. It could be, again, number of different ways that you're randomly assigning, but having everybody have a label and putting them in a jar or a bucket or something is probably the easiest. But random assignment occurs, doesn't matter how many treatments. You might have 30 treatments, so you better randomly assign into 30 groups in that situation. And that's what makes an experiment fair. Okay, you can't choose the 10 healthiest people to get one medicine and the 10 most sick to get the other medicine. That would be an issue. So randomization, in any experiment, you do need to talk about that. So I write RA here, but you would write a sentence or two about how you randomize. So that's an important piece. So the principles of experimental design, these 3 here. Control just means there's going to be comparison. So there's going to be at least 2 treatments. The randomization we just talked about. Replication just is the idea that you get those results over either multiple individuals in each group or over multiple experiments. that the results didn't just happen where you had one person take the new medicine, one person took the old medicine, and the new medicine happened to win in that situation, so you sell the new medicine. The results need to be shown to be consistent, and not just happen in one scenario in one small experiment. So it could be by having a lot of individuals or items in your experiment, or it could be by running the experiment over and over. Hidden bias is the idea of the experimenter trying to influence the results. So that actually kind of goes hand in hand with double blind in medicine examples. Hidden bias is generally can be pretty obvious where the experimenter wants the results to end up a certain way, and so the experimenter will set it up as such. Again, that could be putting the most sick people in one group and the healthiest in another group, or it could be um, trying to give certain dogs certain dog food and less healthy dogs the other dog food or whatever it happens to be. So just at the bottom here, you're seeing kind of a general breakdown of how you set up an experiment. Okay, this is what's called a completely randomized comparative experiment, and that means that we randomly allocated the subjects in this case to two groups. Again, that could be people, it could be cars, it could be uh, gardens, could be cornfields. But we randomly assign them, and then again, we'd write a sentence down here about what randomly assign is. Okay. And then we've got our groups. Again, our number of groups is always going to match our number of treatments. So that the number of different treatments we have is going to determine how many groups we have to break them into. Again, this was an example up here with the commercials that we needed 6 groups. So if we had 60 individuals there, we would break them up randomly into 6 groups in that situation so that we could apply each of our 6 treatments. And then at the end, we compare results. And for comparing results, again, we have to give some more specifics about how we're going to compare the results. And again, that could just be we're looking at people rating their headache before and after. In that matched pairs example, up top with the Coke and the Pepsi, it might be that everybody gives Coke a rating and Pepsi a rating, and we subtract it, Coke minus Pepsi for all of them, and see if that number is positive or negative. And then we run a test on it to see if it's statistically significant in terms of being positive or negative, and that would tell us if it were that one soda gets rated more highly. Um, so this is all about running experiments, thinking about the parts, particularly around randomization and how we compare results, and then understanding what a treatment is and why experiments are set up the way they are. I hope that helps on the idea of experimental design. Thank you.